So we've been looking at taking derivatives of natural log functions, all right? And here what we're going to look at is kind of the inverse idea. Again, integrals are not exactly inverses, but they are kind of like inverses. What we've been looking at here is that the derivative of the natural log is 1 over x. And we had the limit on the domain here that the absolute, or that x had to be greater than 0. And then we also said that the derivative of the natural log of u, if we have a composite function, is u prime over u. Okay? Now, again, u has to be greater than 0. So let's look at integrals. The integral of 1 over x dx is the natural log of the absolute value of x. All right? We expanded on this derivative rule so that we did not have to include the x greater than 0. If you recall, we said that the derivative of the natural log of the absolute value of x was simply 1 over x. And we said that the derivative of ln of the absolute value of u was simply u prime over u. Okay? Well, here, you'll notice we're actually using these kind of more specific rules in our integration, okay? The integral of 1 over x dx is the ln of absolute value of x plus c. The integral of 1 over u du is ln of the absolute value of u, okay? Now this second form, we actually have a little bit of a variation, okay? Because a lot of the times, we might get a 1 over u du if we've done u substitution, but the original function may look slightly different, okay? So it's worth recognizing this second part here. Du dx is u prime, okay? So du is u prime dx. All right? It's kind of like we're doing the u substitution a little bit here. However, if I can then rewrite, instead of making this a du, I can replace the du right here. I'm replacing the du with u prime dx. And that gives me a modified version of this formula where instead of 1 over u, I actually have u prime over u dx. Okay? So here's the u prime dx that I replaced that du with. Does that make sense to everybody? Okay? So there's kind of two forms of this that we can use, and then that's just the natural log of absolute value of u plus c. We will see a couple of examples of this here in just a second. Okay. All right, so let's work through a few of these, okay? If I'm doing the integral of 2 over x dx, well, I know that since the 2 is a constant, I could pull that out of the integral, so it's the integral, 2 times the integral of 1 over x dx. And the integral of 1 over x dx I know is ln of absolute value of x. So this is 2 ln of absolute value of x plus c. Okay?
Mr. Dixon?
Yes.
If we want to, is it possible to get rid of absolute value by putting 2 inside the ln, which will make x squared, which implies absolute value? in this case.
In this case, yeah, I mean, you could use the rules for logarithms at this point, I guess, if you wanted to, make that ln of x squared. And then that will always be, positive. That could work. All right. You do not have to, though. That may be helpful, though, in some cases. How about number 2? Here's where this second form can come into play, all right? I can take the integral of u prime over u. Well, u here is 4x minus 1. So what's u prime? 4. So how do I get a 4 up here instead of a 1? I multiply by 4, but then I have to multiply by 1 over 4 as well. And I'll multiply by the 1 over 4 on the outside of that integral. So now, that is the integral of u prime over u, which is ln of the absolute value of u. Okay? U is 4x minus 1. U prime is 4. Okay? So I'm doing the absolute value of u, 4x minus 1, and then I still do have that 1/4 on the outside. So it's 1/4 ln of absolute value 4x minus 1 plus c. Okay?
Plus C is driving me crazy.
Yep.
Driving me crazy.
Ha ha ha. Crazy.
It was like the way I pronounced crazy. It was like I said the C.
All right. Example 3 here. How would I make that into a u prime over u? U equals
3 minus x cubed.
3 minus x cubed. What's u prime?
3x squared.
Negative 3x squared.
Saying that, but
So what do I need?
negative 1/3
on the outside.
Yeah, negative 3 here and a negative 1/3 here. Okay? So now I have u prime over u. The integral of that is ln of absolute value of u, 3 minus x cubed. And I have the negative 1/3 on the outside. Okay? So there's a lot of, you got to think, and basically, obviously since we just learned this is right on the forefront of your mind, so anytime you're seeing these, you're looking for this idea of a u prime over u. But let me just encourage you, anytime you see a rational function like this is one of the things that should come to mind. It's just, it's kind of like when you see, if you saw a rational function but there was a monomial in the denominator, you're automatically thinking, hey, can I split it up into separate fractions and reduce each one, and then I can use power rules and stuff. Well, here, if you have a rational function and there's it's not a monomial in the denominator, you should be thinking, hey, can I make that into a u prime over u situation and get this to work out? Okay? All right, here it says use logs to find the area bounded by the graph of y equals x over x squared plus 1, the x-axis, and the line x equals 3. Okay, so we're trying to find the area of this region right here. Okay, how do we find area?
integral.
Yeah, taking the integral. Okay, so here's our function. We're going to take the integral to find this area. So the integral of x over x squared plus 1, and we're going to take the integral from what to what? 0 to 3. Now, I see a rational function. It's not a monomial on the bottom, so I'm thinking u prime over u. Do I have u prime over u?
You probably x squared plus 1, but you need to get a 2 up top.
Yeah,
One half on the outside.
yeah, u is x squared plus 1, u prime is the 2x. So you're right, we need to get a 2 on the top. So I'm going to put a 2 there and a 1/2 out here. And that will then let me do 1/2 times the integral of u prime over u is the natural log of the absolute value of u, x squared plus 1.
Let's see.
Plus c. Now, we're doing a definite integral. So in this case, I don't need the plus c because I'm going to be evaluating this from 0 to 3. Okay?
So close, Alex, so close.
So, we have here 1/2 ln of the absolute value of 10, which is just 10, minus 1/2 ln of the absolute value of 1. Okay, which is just 1. Now, what's ln of 1? 0. E to the 0 is 1. So this whole thing equals 0. Let's do that a little nicer. That's 0. So this is just 1/2 ln of 10. If you want, you could write it as ln of the square root of 10, but you don't need to. Okay? So there's an example where we had this rational function here. It was part of a hyperbola of some sort. We were able to find area using this property. Alright, so for some extra practice here, let's run through a couple more of these examples. We should be getting a little bit more comfortable each time we do it. Okay, so let's look at A here. Again, I see a rational function that has a binomial in the denominator. So I'm going to look for my u prime over u. Do I have u prime over u? Yeah, actually, u is x cubed plus x, and u prime is 3x squared plus 1. So actually, I already have the u prime over u, so I can just jump right to my answer. This would be ln of the absolute value of what?
X cubed plus
X cubed plus x. Yeah, it's always the absolute value of u that you're going to take the natural log of. Okay? Good. Okay. B. Oh, we got some trig.
I don't know.
All right. We got some trig. What do you think we ought to do with this?
That's very tricky.
You actually could do this a number of different ways.
A number.
Let me just introduce the easiest way. If we think of 10x as u, then we find the du, which is secant squared x, and then we see that the integral is just simply u prime over u, which is equal to ln of 10x plus c, ln of absolute value of 10x plus c.
Yeah. ln of the absolute value of tangent of x plus c. Okay? Anytime you're seeing trig in the integrals, at least think about like u substitution, or if it's in a ratio like this, think about u prime over u. Okay? could we have substituted something in for sine? Or, not sine, secant squared?
Yes.
Tangent prime.
Well, it is. Or what else does secant squared equal?
Oh,
Think of our identities.
Pythagorean,
The Pythagorean identities.
I don't remember
Oh,
what it was.
1 over cosine squared.
It is 1 over cosine squared. Or, what are the Pythagorean identities?
1 minus
1 plus tangent squared equals secant squared.
Yes.
So, if I made this 1 plus tangent squared over tangent, I could then split it into two separate fractions. So I'd be taking the integral of cotangent x plus tangent of x dx. Now, do we know the integral of cotangent or tangent yet? No. We'll be learning that next week. Okay? But once we knew our rules for the integrals of trig functions, that would be another way that we could do this one. Alright? Now, is that more complicated? Definitely.
Yeah.
Alright? So is that the best way of doing it? Probably not. But we could. Alright? We could. And that's one of the cool things with math. You could do the same problem a bunch of different ways sometimes. So, if we had used 1 over cosine squared, and then we made tangent into sine over cosine, and we flipped and multiplied, and we canceled one out. Okay, there we would have some other things that we could work with. Okay, in fact, if I had done that 1 over cosine squared, and then I am dividing by tangent, so that's times cosine over sine. Okay, the cosines would cancel out, and I'd be taking the integral of 1 over sine times cosine. Alright? I don't know what the integral of that is either. But that would be one path that you might take as you're thinking through the problem. Okay? You just gotta think it through. Alright, let's move on to C here. Okay? What would U equal?
X squared plus 2x.
X squared plus 2x. So U prime is
2x plus 2.
2x plus 2. Do we have that?
Now you gotta multiply by 1/2. Multiply the top by 2.
Okay, multiply the top by 2 and multiply by 1/2 outside, and that'll give us a U prime over U. So this is going to be 1/2 ln of absolute value of x squared plus 2x plus c. Okay. Last one here. What do we do?
1 times 1 over 3.
Okay. 1/3. And that makes that a 3. Okay, so what's our answer here?
1/3 times x 3x plus 2.
There you go, good. 1/3 ln of the absolute value of 3x plus 2 plus c. Okay? Alright, so that's an introduction here to finding integrals of functions where it ends up being a natural log, okay?